Hello everyone, welcome back to my YouTube channel. This is Rachana from Sri Venkateshwara College of Engineering, pursuing first year in BE Computer Science and Engineering. Today in this video, let us discuss on the topic applications of polar coordinates. Introduction to polar coordinates. The polar coordinate system is a two-dimensional coordinate system in which each point on a plane is determined by a distance from a reference point and an angle from a reference direction. The reference point is called the pole and the ray from the pole in the reference direction is the polar axis. The distance from the pole is called the radial coordinate, radial distance, or simply radius, and the angle is called the angular coordinate, polar angle. Angles in polar notation are generally expressed in either degree or radius. So next let us move on to the graphical representation of a polar coordinates. Next, overview of a graphical representation of polar coordinates. In polar coordinates, points are represented by distance from the origin and an angle measured counterclockwise from a reference direction. This graphical representation is often called a polar plot or polar graph. Next, what is radius? The distance from the origin to the point. Next, angle. The angle formed by the line segment connecting the origin and the point measured in degrees or radius. Next, how to plot a point in polar coordinates. First, we have to measure the angle theta from the reference direction. Extend a line from the origin in that direction for the specified radius r. The resulting polar plot can depict various shapes like circles, lines, or more complex curves depending on the function describing the relationship between r and theta. For example, the polar equation r is equal to 2 by sine 3 theta would create a polar plot with 3 petals resembling a flower. Understanding polar coordinates is useful in contexts like physics, engineering, and mathematics, especially when dealing with circular or symmetric patterns. Next, let us move on to polar coordinates formula. Polar Cartesian coordinates are a way of representing points in two-dimensional plane using a distance from a fixed point called the pole or origin and an angle from a fixed direction, usually the positive x-axis. The polar coordinates of a point P can denoted as where r is the distance from the origin to the point P and theta is the angle that the line connecting the origin to P makes with the positive x-axis. The conversion between polar and Cartesian coordinates can be done using the following formulas. To convert Cartesian to polar coordinates, r is equal to square root of x square plus y square. To polar to Cartesian coordinates, x is equal to r by cos theta, then y is equal to r by sin theta. Next, let us move on to the applications of polar coordinates in physics. First, rotational motion. In rotational motion, polar coordinates are often used to describe the motion of objects undergoing circular rotation or rotational motion. The angular coordinate represents the angle of rotation while the radial coordinate gives the distance from the center. Figure 1 is the example for rotational motion of polar coordinates. Electric and magnetic fields. In electromagnetism, polar coordinates are employed to express electric and magnetic fields around the charged or magnetized objects. This is particularly useful when dealing with systems exhibiting cylindrical or spherical symmetry. Figure 2 shows electric and magnetic fields of polar coordinates. In wave propagation, polar coordinates can be useful in describing wave propagation, especially circular or spherical waves. This is relevant in fields like acoustics and optics. Next, in gravitational fields, when analyzing the gravitational fields of symmetric objects such as circular plates or rings, polar coordinates simplify the mathematical expression and make it easier to describe the gravitational effects at various points. Fluid dynamics. Polar coordinates are applied in fluid dynamics to describe the velocity field of rotating fluids as well as in problem involving circular containers or rotating systems. Heat conduction. in problems involving heat conduction with radial symmetry. Polar coordinates are advantageous. This is common in scenarios like heat flow through a cylindrical or spherical objects. Quantum mechanics. In quantum mechanics, polar coordinates are used to solve certain types of problems such as those involving spherical symmetry like the hydrogen atom. Optics. When dealing with optical systems with rotational symmetry such as lenses or mirrors, polar coordinates simplify the analysis of light rays and image formation. Next, applications in engineering and design. In first rotating machinery analysis, engineers use polar coordinates to represent forces, movements, and velocities in rotating machinery such as turbines or engines. This helps in understanding the dynamic behavior of the components. Next, antenna design. Antenna patterns, which describe how antenna transmit or receive signals in different directions, are often represented in polar coordinates. This helps engineers visualize and optimize the antenna's performance. Robotics and motion control. In robotics, polar coordinates are used to plan and control the motion of robotic arms. This is particularly useful when dealing with circular or rotational tasks, allowing precise control of the end effector. Wind turbine analysis. Polar coordinates are applied to study wind turbine performance. Parameters like wind speed and direction are often represented in polar forms to analyze the efficiency and power output of the turbine under varying conditions. Polar coordinates provide a convenient way to represent and analyze rotational components, simplifying complex calculations and visualizing patterns and relationships in more intuitive manner. Next, conclusion. Polar coordinates offer a flexible way to represent points in a plane using distance and angle, providing crucial in diverse fields. They simplify complex geometry problems, enhance accuracy in physics and engineering applications, and are fundamental in computer graphics. From astronomy to navigation, polar coordinates provide a powerful tool for expressing relationships and analyzing phenomena with ease. So, thank you for watching this video. Please like, share, and subscribe. Take care. Bye bye.